In this collab, we learn the probability for deep learning. So first we install all the required libraries such as NumPy, Matplotlib, Seaborn, SciPy for probability demonstrations. So first we define the sample space for a fair die rule, which creates events for even numbers and numbers greater than 4 and calculates the probabilities. So here we visualize the sample space and events using colored rectangles to show which outcomes belong to event A, which is even, and B, which is greater than 4. Here we demonstrate classification as probability by applying softmax to the neural network logits, printing class probabilities and visualizing the output distribution as a bar chart. Here we illustrate probability rules using die rule examples, computing complement probabilities union intersection of events with their formulas. Here we visualize the Venn diagram, which shows the overlap between events A and events B, with probability formulas displayed below the diagram. And here we demonstrate the conditional probability using a medical test scenario, calculating the probability of having a disease test sensitivity and false positive rate. Next is we apply Bayes' theorem to calculate the probability of having disease given a positive test result, showing that it's only 8.7% despite 95% of testing accuracy. Now we visualize Bayes' theorem with population breakdown chart and the pie chart showing true positives versus false positives among positive test results. So the expected calculations value for fair and loaded dice, comparing theoretical values with simulation results from 10,000 rules. Here we compute variance and standard deviation for a fair die, then plot normal distribution with different variances to show how spread increases with variance. Here we implement Bernoulli distribution properties and demonstrate dropout as Bernoulli sampling, and with a mask applied to neuron activations, and visualizes both the MF and dropout effects here. Here, and this is the explanation of Gaussian distribution properties, including the 68, 95, 99.7 rule, and visualizes the standard normal distribution with shaded regions for each sigma range. So here we implement a he and savior weight initialization methods using Gaussian distributions. Here we compute entropy for 4 different probability distributions: uniform, peaked, very peak, certain, and then visualize them to show how entropy measures uncertainty. And then we implement the KL divergence functions, computes divergence between a true distribution and 4 comparison distributions, and visualize with bar chart showing distribution differences. Similarly, we also calculate the maximum likelihood estimation of both distributions. And in the end, we implement dropout layer with Bernoulli sampling.